Now let's talk about partial differentiation. To talk about partial differentiation in lessons, you need to be familiar with something called multivariate function. A multivariate function is a function that has more than one independent variable. Usually, it's represented with uppercase z. So consider z to be equal to a function of x, y. In this case, z is said to be a multivariate function, as z is a dependent variable and it depends on x and y values. Now, if you are willing to determine the effect of the change in the independent variable x or y on the dependent variable z, then the use of partial differentiation is introduced. So basically, partial differentiation is a technique that helps us to determine the effect of the change in the independent variable on the dependent variable. Am I communicating? Perfect. So now, the partial differentiation of z with respect to x tells us the change in the dependent variable z with respect to x, while y will be held constant in that function. Similarly, the partial derivative of z with respect to y tells us the effect of y on z, while x is held constant. Now, there are some notations you have to be familiar with, which is as follows. Di z di x, which is basically the way we read it, tells us the partial derivative of z with respect to x. However, there are some other similar notation that is used to represent di z di x. This can also be represented as di f di x. This is the same. Similarly, you can have it as z sub x. And likewise, you can have it as f sub x. So whenever you see this in any context, what it makes sense is that it means the partial derivative of z with respect to x, while the independent variable y is held constant. As we proceed forward, I'm going to show you how you are going to differentiate partially the dependent variable with respect to any of the independent variable. Am I communicating? Perfect. Now, also, we have the partial derivative of z with respect to y, which we read as di z di y. And this is in another way written as di f di y. Or in another way, we have z sub y or f sub y. Now, how do we differentiate z with respect to x or y? Let's look into that in essence. Well, for you to understand this properly, it will be better if we consider using some examples. Consider z to be equal to 3x cubed y squared. And let's say you are required to find z sub x and z sub y, where z sub x represents the derivative of z with respect to x, and z sub y represents the derivative of z with respect to y. So, to get the solution to z sub x, basically, the first thing you have to consider doing is to treat y terms as a constant by mentally bracketing them. However, in that process, take the coefficient along. By mentally bracketing them along with the coefficient. What am I saying next sense? We want to treat y terms as a constant, that's y squared. However, we're going to attach the coefficient to it. So let's put this in the bracket, 3y squared. Perfect. Then we have x cubed. So upon doing that, you are trying to make things simple for yourself. Now, upon treating the y terms as a constant along with the coefficients, differentiate the x term with respect to x. So it means that we have z sub x to be equal to 3y squared in the bracket cube. Then we are differentiating the x term with respect to x. Am I communicating? You don't need to write all this process. I'm showing it out for you to see the beauty. Am I communicating? So it means z sub x will now be equal to 3y squared multiplied, bracket, multiplied by the derivative of the x. Okay, this is squared actually, not cube. I'm mixing it. 3y squared multiplied by d dx of x cubed. That's simply 3 x squared. Now, eventually, you can multiply everything together and have your series of x. So the derivative of, or the partial derivative of z with respect to x is simply 9y squared x squared. And that's simply our solution. Am I communicating? First step, treat the y terms as a constant along with the coefficients. And this step is if you are differentiating partially with respect to x. Then having done that, differentiate the x term with respect to x. Then eventually multiply your results together and have your final answer. The same process applies to if you are differentiating with respect to y. But it's just that instead of treating y terms as a constant, we are going to treat x term as a constant. So let's look into that. So let's have that in here. So to find z of y, first we need to treat the x terms as a constant along with the coefficients. So by bracketing it, this clearly means that z of y would simply be equal to, so put this in the bracket 3x cubed, and then we differentiate these, or let me just write it first, times y squared. So having done that, having mentally bracketing the x terms along with the coefficients, we can now have our z of y to be equal to, basically we want to differentiate y squared with respect to y. Then we have 3x cubed times d dy of y squared. Perfect. Thus, we now have 3x cubed multiplied by the derivative of y squared with respect to y is simply 2y. And then, doing the product, we eventually have 6x cubed y. And that's simply our partial derivative of z with respect to y. How do you got that? So guys, this is how you can easily differentiate a multivariate function with respect to any of the independent variables. To understand this more better, let's consider a few examples. Example number 2. Consider the multivariate function z that is equal to 5x cubed minus 3x squared y squared plus 7y to the power of 5. So feel free to pause the video and find a solution to z of x and z of y, which is in other word written as di z di x or di z di y. Perfect. So now let's begin. So to find di z di x, which is z of x, first and foremost is that we want to treat the y terms as a constant by mentally bracketing them, okay, along with the coefficients. So this has no y term, we leave it as this. So we have 5x cubed minus these as y terms. So we are taking the coefficient along with it, and so therefore we will have the bracket 3y squared, okay, and we multiply with x squared. This has no x term, so we have plus 7y to the power 5. Since there's a y term, let's put it in the bracket. Am I complicated? Perfect. Now to make this easy, because we are going to do something here, do you agree with me that I can actually introduce x term to be attached to this? How? By just multiplying it with x to the power of 0. This makes sense because x to the power of 0 is simply 1. And 1 multiplied by this expression gives me back the expression, so it doesn't change anything. It's just the structure that's changing. But the results still remain the same. Am I complicated? The reason why I'm doing this is I want you to see how this will eventually turn to what we are going to say turns to. Am I complicated? Perfect. So now let's proceed forward. So now to now get our final answer to this of x, we can now differentiate the x terms with respect to x. So d dx of 5x to the power of 3 is simply 15x squared. When you differentiate this, you should have that. Then minus, we have 3y squared. Okay, we are multiplying times. If we differentiate x squared, that gives us 2x. Then plus, then we have 7y to the power of 5 multiplied by. Now, what is the derivative of x raised to the power 0? Well, since x raised to the power 0 means that that's simply 1. That's a constant. It means the derivative of 1 is simply 0. So that's 0. So now 0 multiplied by this entirely is simply 0. So it means our z of x, which is our final answer, would be 15x squared minus 6xy squared. Then this is plus 0 and That's our final answer. So like I said, the main reason why I actually introduced the x power 0 is to show you how this eventually results in 0. So now let's find the solution to this of y. So we're going to get rid of this one. So to differentiate partially with respect to y, we need to treat the x term as a constant. So this is x term. Since there's no y term here, let's have it as y is power 0 multiplied by, and let's take it as a bracket, so as a constant, put in the bracket 5x to the power of 3, the minus. So now we have x term here, we can put in the bracket minus 3x squared multiplied by y squared plus 7y to the power of 5. There's no x term. That's alright. Can now differentiate with respect to y, each of the term that has y. So our answer is now this of y equal to, this is y raised power 0, which is a constant, and derivative of constant with respect to y is simply 0. And 0 times this entirely is simply 0, so we have 0 minus. Now we have 3x squared multiplied by derivative of y squared is simply 2y. And we have plus derivative of 7y to the power of 5 is simply 7 times 5 times y to the power of 4. Okay, don't forget we are differentiating with respect to y. So the product of these two is simply minus 6x squared y, and we have plus 7 times 5 is 35 y to the power of 4. I don't know what's wrong with the tablet, it's just lagging. The pressure seems not to be perfect enough. It's just behaving somehow. Well, I'll check it out. So this is our result to this of y, and that's it. So I hope you find this helpful and understandable. I want to believe by now you should be able to differentiate a multivariate function with respect to any of the independent variables. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So this exercise I have for you, consider finding z of y and z of x for a given multivariate function z equal to 7x squared plus 9xy then plus 2y to the power of 5. So feel free to share your solution with me via the comment section below. Thank you once again. Bye for now.